In this video, we're going to look at my version of a doubly linked list in Python, and then we're going to talk about two kinds of special doubly linked lists, stacks and queues. Alright, so just as a reminder, we can think of a representation of a doubly linked list like this, where we have these rectangles represent some kind of information we're storing, and then these double arrows represent links between that information. Each one of these boxes where we're storing some information, we call those nodes, and then these are the links or the references. Okay, so the first thing I did is set up a class for each node, and we're going to pass into that class some information. I'm going to just call it X, and then we're going to pass in two links, the previous node and the next node. And then I set this up so that each node has self.previous, self.next, and then the data. And then we have a string method for this class where if we want to print out a node and we just print out the data, we don't print out the links to the previous or next node in the list. Okay, so now we're ready to set up our linked list. And maybe I was too quick to close. Oh, no. My picture. So what we have in the init is we're going to keep track of a head and a tail. So the head is going to be the start of the list, and the tail is going to be the end of the list, or the last thing we put on is. And initially these are there is no list, so initially these are both none. So when we create a linked list, we start off with a head and a tail that are none, and that's it. Now we can, with this list, there's two methods that I have created, and then you're actually going to be responsible for creating some further methods. We can push something onto the list, which means add it to the list, and we can print the list. Okay, so when we push something onto the list, we pass in some X, so this is some information. The first thing we do is create a new node. So we're creating one of these boxes which has then some links in it. And then we check if the head is none, which means that the list is empty, then we set the head equal to the node we've just created. And there is no previous or next, so we make sure that those are none. Actually, those were already set to none. Up here as optional parameters, since we didn't pass those parameters in. Previous and next were already none, but I don't think anybody's ever been hurt by double checking, making sure that their variable is initialized. So we make sure that this is the only thing on the list. So at this point, all we have is this one node, no links to anything else. And then the tail is the same thing in the head in this case. There's only one element to the list. Okay, if the head is not none, in other words, we have then a head to this list, there's already something in the list, then we need to add it in. So we could be adding in here anywhere. So we're going to have to do two things. We're going to have to create links between this new node that we have. So picture we've got a new node here. And it's going to go on the end of this list. So we create the node, and then we have to create a link from this node back to the old tail, and from the tail to this new node, and this is then make the new node the tail. Right? So once again, we create a new node, we link it back to the tail, we link the tail to the new node, and then we move the tail to this new node. Alright, so if the head is not none, first we link the tail to the new node. So self.tail.next becomes node. Then we link the new node back to the tail. So node.previous equals self.tail. Just check to make sure that there is no next. This is going to be the end of the list. So we set that to none. So there is no next. And then we set the tail to the new node. So that then creates our list and adds something to the end of the list. In terms of printing the list, then we want to start at the head. So we set node equal to self.head. And while node is not none, remember the end of the list comes when we get a none for our next link. So while node is not none, we can add string of node to our string. And remember that we have a string method for each node. So we add this node into our string, and then we go to node not next. So we'll start at the beginning, at the head, then we'll go node not, oops, I didn't want that. We'll go node not next, which will take us to this node, then node not next to this node, and to this node, and we'll go all the way through the end of the list until we run out of links, until there is no next. Okay. So I created a simple linked list. I instantiated linked list as numbers, and then I'm going to start. Now when you do that, remember that all that does is create a head and a tail, which are none, so we really don't have much at this point. Then I'm going to add a bunch of stuff to my list. So the simplest way to add a bunch of stuff is just to do a quick for loop. So for I in range 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and push I. You can push anything you want. X can be any data structure, any Python data structure. I chose to use integers because, again, this is the simplest way to add a bunch of stuff to a list. And then we'll print the numbers out. So this will, on the first go around, create a head, which will be at 0. And then after that, we'll add a bunch of nodes. And then in the end, we'll loop through those nodes and print them out. And we'll run this. And there you go. So now we have all this code here to basically create then ultimately what looks a lot like an array. So you may be thinking, well, gee, that's a lot of work to create something as an array, but you might want to reverse that thought process and say, oh, an array is in fact probably a doubly linked list. Okay, so this is my implementation of a doubly linked list in Python. The code is up on GitHub for the activities related to linked lists. And again, you're going to be adding to this code. So one of the things that is not in here is you can add stuff to the list, but there's no way to delete anything from the list. And when you add, you're always adding to the end of the list, but that may not be the way you want to do it. So there might be other ways to add things to lists. So the second half of this video is going to be about two special kinds of linked lists, stacks and queues. Okay, so to finish up this video on doubly linked lists, I'm going to look at two particular kinds of doubly linked lists. A stack and a queue, or a stack is known as LIFO, last in, first out, and a queue is known as FIFO, first in, first out. So let's pretend that we have then some people that we're adding into a list. So I'm going to add in Jim, add in Jane, so I'm just pushing these people into our doubly linked list. All right, that's enough people. So each one of these doubly linked lists has the same people in them. So it's not, the lists are not maintained how you add people, it's how you remove people that matters and what separates a stack from a queue. And with both of those, we're always removing from the end. It's just a question of which end we remove from first. So remember that these people were added in this order. Now suppose that we're going to start removing people. In a stack, when you remove something, it's called a pop. You can also use that for a queue. For a queue, it's also called dequeuing. So if I want to remove somebody from the stack, it's last in, first out. So the last person in gets removed first. So if I'm going to remove something, I do a pop, then Robert goes. Whereas with a queue, if I'm going to remove somebody, then it's first in, first out. Since Jim was the first person in, if I remove somebody from the queue, if I pop somebody from the queue or DQ them, then Jim is gone. And so with the stack, as I do pops, I pop off Fred, then Jill, and then if I'm going to add somebody, that person would go on the end of where the current list is. So I might add a couple people in again, but then when we start removing, we're always removing from this end of the list. The last person on is the first person out for a stack or a LIFO. Whereas with a queue, if you're the first person in, you're the first person out. This probably seems more normal in some sense. FIFO lists. These are the sorts of lists that you expect when you get in line for a movie ticket or get in line to get some food at the cafeteria or whatever. You expect if you're the first person there, you're going to be the first person served, not the other way around. So we'll have to look at some applications for these, and this will be the subject of a next video. Why would you want a stack? Why would you want last in, first out versus a queue? Your job is going to be to implement a stack and a queue based on my code that I shared with you for a doubly linked list.